This will be a continuation of how to use some of the identities on the reference sheet I gave you guys for simplifying different trigonometric expressions. So one of the skills we're going to focus on today is how to take a fraction and separate it into two different smaller fractions, because sometimes that will allow you to use different trig identities to break things down and cancel terms out. The main thing I want to emphasize on this is make sure you are only trying to split the numerator, not the denominator. You can only do this when you have multiple terms, so there have to be some pluses and minuses on the top of a fraction like this. So what you can do is take each term in the numerator and put it over the denominator and make those different fractions. What you cannot do, and you absolutely should never do this, is take one numerator and put it over both things in the bottom. That is not something you can do. Make sure you understand the difference between these two cases. So here's an example. I see two different terms because they are separated by a plus sign in the numerator of my fraction. So I'm going to break this down as 1 over cosine of theta. And then the sign doesn't change in between. So since I had a plus, it's going to stay as a plus sine over cosine. Now when I had this combined, I didn't see any identities I could apply to make things cancel out. But looking at this as 1 over cosine of theta, this one I recognize from the reciprocal identities. That's equal to secant of theta. And separately, sine over cosine matches our definition of tangent of theta. So the point here is to look at things broken into smaller, more manageable pieces, and then see if you recognize any of the identities from your reference sheet. This next example is near identical. I'm not actually going to work it out just because it would be so similar to the last one, but it would be a good one for you guys to pause and try to do on your own and see if you get a similar result. Another strategy I wanted to go over with when dealing with fractions is if you have multiple fractions, sometimes it's good to get a common denominator and combine them together. Make sure you are comfortable with how to add two fractions like 1/2 plus 1/3, because you often need to multiply by the denominator of the other fraction. And then once you have the same denominator, you can combine them into one with only the numerators being added or subtracted. So here's an example. I see one fraction plus another fraction. Now these fractions do not have common denominators. So for the fraction on the left, I'm going to have to multiply top and bottom by cosine. And for the fraction on the right, I need to get the 1 plus sine of x in the denominator. So I'm going to have to multiply top and bottom by both of those pieces, 1 plus sine of x. When I compute this, cosine times cosine is equal to cosine squared of x. And you can either write cosine of x in parentheses and put the squared on the outside, or you can write it like this, cosine squared of x. It's just two notations for the same thing. For the 1 plus sine of x times 1 plus sine of x, you're probably going to want to FOIL that out, so I'll try to show that in just a second. The denominator of our fractions are going to be the cosine of x times 1 plus sine of x. So I'm just going to leave those as two separate pieces. And then see if anything will be able to cancel out or reduce from the other computation I was talking about. So if I FOIL this one out, the first piece you have is 1 times 1. And then for the outside, you get sine of x. For the inside, you get sine of x. So combining the outside and the inside products gives you 2 sine of x. Or instead of distributing that out, maybe you know the property that having the binomial a plus b squared is a squared plus 2ab plus b squared. The last piece is sine of x times sine of x. Now, at first glance, it does not look like this actually did anything for us. It doesn't seem like it's simplified. But because of the commutative property of addition, don't forget that you can rearrange some of these things. So what I'm going to do is I'm going to take this sine squared of x and move it all the way to the front so that I see sine squared of x plus cosine squared of x. And that's the part I really want to focus on for a second. The reason it's helpful for me to do that is because you will hopefully recognize sine squared plus cosine squared from the trig identity reference sheet. I'll show you this identity in just a second. So by grouping those two together, now I can look on the formulas I've given you. And there's one that says sine squared plus cosine squared is equal to 1. So I'm going to perform that substitution. We did it in the earlier notes as well. Sine squared plus cosine squared is 1. So I'm grouping all of that together. And I'm also going to go ahead and combine that 1 plus that 1 is equal to 2. Now this also opens up another option for me, because now I see a factoring step I could make. In the numerator, my two terms each have a 2 in them. So they have something in common. The GCF is 2. So if you factored that out, you'd be left with 2 times 1 plus sine of x. My denominator I have not been changing since my initial step. I know it seems repetitive, but it's really hard to read somebody else's work if they do not clearly write out the terms, even though it might seem repetitive. It's really hard to read this if I was just trying to skip a lot and be as lazy as I could by not writing the denominator over and over and over again. But at this point, you can see now that the 1 plus sine of x will cancel out. So now I can mark them out and just write that my final answer is equal to 2 over cosine. And remember, the reciprocal for cosine is equal to secant. So this would be 2 times secant of x. So what we just determined was this big, ugly original expression was actually all equal to 2 times secant of x, which is a lot easier for both people or machines to compute answers. So the idea here is that we're breaking them down into more manageable parts. Why use the complicated, ugly expression if there's a simpler expression that has the exact same value no matter what? So make sure you focus on things one at a time. Try to just keep some of those guidelines in mind. What are the things you're looking for? If you see multiple fractions, try to combine them. If you see one fraction with multiple numerators, try to split them up. And don't forget the strategies we've looked at in previous videos. We still have another section in this unit where we'll be looking at a couple more strategies. Now again, I do have another example here that would work out very similar to the one I just showed you with example 7. So I'm not going to work it out, but it would be good for you to try and pause and see if you can compute the steps on your own. That's all for the notes today, though. Thank you.